In this video, we'll begin exploring some of the more common polymers that exist. Now, we're going to start by looking at natural polymers, that is, polymers that occur and are produced by living things. And so we can start looking at vegetable and animal fibers in that vein then. And so cotton and linen, these are what we call vegetable fibers. They are derived from plants. Wool and silk, these are fibers that are derived from animals. And what's interesting about both of these sets of materials is that while they have natural resources as their kind of starting spot, both can be altered chemically to produce synthetic fibers. And that's actually what happens often in these industries, because cotton on its own has this property, but not necessarily this other property that we want to have. So we make a modification, we get it to go the way that we want it to go. Now, one of the more common other types of natural polymers are cellulosic polymers. Now, cellulose is derived primarily from plants. It is the primary ingredient in cell walls. And in wood sources, you have cellulose, and you also have another binding agent called lignin. And what happens is if you chemically remove the lignin from the wood source, what is left over is just that cell wall material, the cellulose. And cellulose makes basically the raw material for a lot of things: papers, natural woods, cotton textiles, cellulosic plastics, which has been a up and coming kind of category as we've become more and more conscientious of our use of oil for building plastics. In fact, there was one point in time where I believe it was like 95% of the petroleum that was drilled and brought up out of the ground was actually used to make plastics in some kind of way. Only a very, very small portion actually gets used for what we traditionally think of as uses for oil related to um, uh, automobiles, jets, cars, planes, that kind of stuff. But the use of cellulose materials has helped the plastics industry considerably. We've also seen a lot of ground being made up in terms of cellulosic ethanol, which is an interesting application using switchgrass and some other kinds of plants to generate alcohol that we can use for burning combustion things, engines and whatnot. Um, Taking another look at wool and silk, these are our most common animal fabrics. They are actually derived from proteins. And proteins you can kind of think of as a biological example of a polymer. Doesn't quite fit neatly into the pictures that we drew in the first description. Proteins are certainly not addition polymers; they are condensation polymers, but there's not necessarily a repeating pattern to them, like we see with a lot of others. There is definitely a pattern. Certain types of orders of amino acids going in one set of directions or another do lead to certain properties of that protein, but it's not as regimented of a pattern. It's not as simple of a pattern as we might be led to believe, where it's A, then B, then A, then B. There are 20 different amino acids, and they all can be inserted in different places along the way. But they do have some pretty interesting properties, and like other polymeric materials, they will burn, and their ignition temperatures come in somewhere around 10 to 50 Fahrenheit, a little bit higher. Now, the main point of this particular video is to look at these. These are the most common synthetic polymers that exist. They're called vinyl polymers, and they're made from one or more vinyl compounds. Now, in our introduction to polymers video, I showed you the basic structure of a vinyl polymer. We have a carbon double bonded to carbon. We have hydrogens bonded in 3 of the positions usually. There's a little bit of variability here. And then we've got this R group, this wild card, that can change and gives us the different types of vinyl compounds. Vinyl chloride, vinyl bromide, vinyl acetate, you name it. So these vinyl polymers are very common. We find them a lot in textiles. We find them a lot in building materials. We find them a lot in just kind of what we think of as plastics. So let's take a look at some examples. First, polyethylene. Polyethylene comes in 2 forms. High density polyethylene, HDPE, otherwise known as number 2 plastic, or low density polyethylene, LDPE, otherwise known as number 4 plastic. Now, both of these are thermosetting polymers and are usually found in products like toys. We can also see them in water bottles and other things like that. Now, both can be recycled, and I'm going to put a little star next to this. And the reason why is depending upon where you live, you may not be able to recycle number 4 plastic. Here in Vincennes, there was a long period of time where we were able to. Just recently, we were told that they're no longer taking anything but number 1, number 2, and number 5 plastic. So they are both recyclable to a degree, but high density polyethylene is far more acceptable and more universally recycled. Now, when these polymers burn, they release more heat than any other commercial polymer. And that's important to know because that means that we're talking about some really high energy density in these polymers. Let's look at polypropylene, otherwise known as number 5 plastic. Polypropylene, or PP, is used to in a variety of different products. Again, where we tend to see it the most often is in the rigid containers, where things like food containers. It's made out of that somewhat bendy plastic. So it's good for things like yogurt tubs and cottage cheese and some of those other small plastic containers. But it can also be used in formation of fibers, and those fibers can be going into a number of different commercial products, things like shatterproof glass, artificial turf, twine, rope, and carpeting. It is recyclable, it is very commonly recycled. And what's interesting about this is it doesn't ignite easily. It's actually more prone to decomposition. And once it decomposes, the vapors there are flammable, but on its own it doesn't ignite very easily. And for an example of that, I'm going to link to a video here. There was an occasion a few years ago where there was a football game in St. Louis, and part of the turf caught on fire. If you look really closely, it was a pyrotechnics accident. And if you look really closely at the close-up of the field, it actually takes a long time for the field to actually catch on fire and start charring. The pyrotechnics go off. It leads to a reaction, but the field doesn't actually catch on fire. The pyrotechnic, the fireworks are burning on the top, and you can see that it's smoldering the grass underneath, but the grass actually isn't catching on fire until much, much later. It's a cool watch, and so I'll tag it here and link it into the video as well. Polyvinyl chloride, PVC, as it's most commonly known. Vinyl chloride is a flammable gas that is subject to autopolymerization. And on its own, vinyl chloride is a human carcinogen. But when it autopolymerizes, we find it is very useful. It's very rigid, it holds a shape very well, and we find it in a lot of construction materials. It's actually become one of the more preferred ways of doing large scale plumbing. Um, um, it's recyclable, it has a lot of good uses, and it's gained a lot of traction in the recent years as a result. Problem with it is that when it burns, that chloride comes off, reacts with the hydrogen, and makes hydrogen chloride gas. You also see with the use of the chlorides, we can also see the possibility of dioxins. Dioxins are nasty, nasty gases that can cause a variety of different illnesses and potential diseases if you have prolonged exposure to them. So the downside to PVC, while it is a really good building material, it also, if it catches on fire or if it degrades, it can really make some nasty, nasty byproducts. Here's another common, polyacrylonitrile. Um, acrylonitrile on its own is a toxic and flammable liquid, and on its own doesn't have a whole lot of utility for us. But when it polymerizes and makes polyacrylonitrile, we find it used in a lot of acrylic fibers. If you have ever had any kind of clothing or material that says that has acrylic in it, it contains polyacrylonitrile. And where we see that, nitrile rubbers, so nitrile gloves, which are becoming more and more common these days with as many latex illnesses and allergies as exist. Quick drying carpets and textiles. Um, things that have moisture wicking technology in them. Usually use polyacrylonitrile as that means of production. And then brand names for some of those carpet things, Orlon and Acrylan. These are brand names owned by the DuPont company, and have been around for many, many years in carpeting especially. Downside to polyacrylonitrile, that nitrile group is a cyanide group that is covalently bonded. When that covalent bond breaks down and you have cyanide released in that atmosphere, you can get toxic hydrogen cyanide gas as a result. Another type of polymer that we see is called polymethyl methacrylate, and it's another of a series of polyvinyl polymers. We get it from a number of different acrylate kinds of derivatives. On its own, as a monomer, very volatile, flammable liquid. In its polymeric form, we find it used in plexiglass and lucite. And both of those are known for being shatter resistant and pretty strong for being plastic derivative materials. The last one that we're going to look at here is something called polyurethane. Now, polyurethane comes from not so much a vinyl derivative, but when these two substances, glycol and diisocyanate, come together, they form kind of a frothy mix. And as they mix together and they form this kind of frothy material, it eventually solidifies, and that becomes the basis of foam. And so we get these foams that can be used in insulation, sound modification, acoustics, carpet padding, furniture, seat cushions. Pretty much most things that are foam are probably polyurethane foams. And so that's where we're going to stop this particular exploration. Next time, we're going to look at some other more interesting kinds of polymers. Until then, take care.